Back, Bobcats, to today's edition using the quadratic regression formula. So we're going to write and fill out the steps for the quadratic regression formula. So here we go. We're going to take a look. We're going to input our information into the table after we choose a table, and then this is our information we need today, and we'll identify some stuff and be able to write in a quadratic standard form. We haven't talked about that yet. So here's how this is going to go, y'all. We're going to take a look. We're going to say, hey, let's add a table. All right. And I'm going to hit 6 and 7, 9, 11, 15, 17. And then I'm going to go back over here and I'm going to say 28, 41, 61, 72, 80, and 79. Okay. Now I'm going to hit this little magnifying so that way it kind of focuses in on you. Look. You can kind of see, hey, it's going to make a quadratic as it goes up and goes down, whatever. So now what we're going to do is we're going to input this information, y1, shift tilde. We have ax1 squared, so shift 6 squared, arrow down, plus bx1 plus c. Wow, that's a lot. All right, so here's what we need. We need A, we need B, we need C. So A, I'm just going to write all the information for A. We have negative 0.7066617. Then we have 20.6909. And then we have negative 69.6515. All right, and so for the purpose of this, I'm just going to leave all of these numbers as they are, and we're going to write it into the formula or the function. So it's going to read y equals, okay, and we're going to say A is negative 0.70, so negative 0.706617 x squared. And then we're going to put our B value. Our B value comes next. Plus 20.6909 x. And then we have our minus 69.6515. Minus 69.6515. Okay, so now what we're going to do is we're going to type this and see, do I get the same line? So y equals negative 0.706617 x squared plus 20.6909 x minus 69.6515. And there you go. So this is sitting on top of the other one. So that would be our answer. Let me just highlight one more thing. So there's A, there's B, and here's C. Okay. All right. We got another one here. Let's take a look. So we're going to clear out all the information. And we're going to add a table again. And we got 16, 18, 22, 27. The hardest part to this is typing this in correctly, just making sure that you do this right, double checking that it's right. Because if you type it in wrong, then you're not going to get the right thing. And again, it should start making one of these parabolas or quadratic functions. So let's focus in on it with hitting the magnifying glass. There it is. There's the quadratic. All right, so let's run our regression. So here's our formula. We have y1 tilde ax1 squared plus bx1 plus c. And now I have a line going through the dots as best as we can. Let's pull our information for A, B, and C. So we have negative 0.0345146. Again, I'm just writing all the numbers right now. 2.20907 and negative 18.5976. So this equation would read, I'm going to write it kind of over here, I suppose, negative 0.0345146x squared plus 2.20907x minus 18.5976. All right. We got one more. We're going to look at an example from a real world scenario. Okay. So again, we're going to use our regression formula for this. So it goes like this. We've given some information. They're going to tell us some stuff. And they're going to say, write a quadratic regression for the set of data. So this tells me I need to be using that formula right there. All right. And again, we want to identify our A, B, and C, and we'll write an equation using A, using B, and using C. All right, so you can read it. It's talking about a rocket being shot from a launcher, okay, and it represents the height. So time, height. So let's take a look. All right, I'm going to get rid of this and add a table and type my stuff in. 0.2, 0.4, 0.7, 0.9, 1. And then I got 24, 47, 79, 98, and 143. Again, you hit the magnifying glass, it'll focus in on these. Should start making a quadratic function. I don't really know what that's looking like right now, but let's see what we can come up with. All right, so let's type in our regression equation. So we have y1 tilde ax1 shift 6 squared arrow over plus bx1 plus c. There we go. And it goes right through our dots, so awesome. A, negative 14.3224. B, 121.873. C, 0.362737. All right, so now I write my formula. Y equals negative 14.3224 x squared plus 121.873 x plus 0.362737. All right, so now we're going to use our equation to find the height nearest foot for 7.7 seconds. Now, you could go over here and say, okay, where would it be at 7.7 seconds? Well, 7.7 seconds, probably somewhere around, ooh, look at that. We got here. We can do this. 7.71, that's 88.619. Well, let's check it if I use the formula. So here's how I would check it. I would say, okay, here's y equals negative 14.3224 x squared plus 121.873 x plus 0.362737. All right, and so if we turn this to a table, this one, and I put in 7.7, what is happening? What is wrong with my formula? Oh, okay. I just couldn't see the numbers. All right. So if we put in 7.7, again, for whatever reason, I don't know why it's not showing up very well. 7.7. There we go. And that's the same number that we just saw a minute ago with the 89. Okay? So, thanks for watching, guys. That concludes our notes for today, and we'll check you next time.